So in this lesson, what we're going to do is basically perform all the same operations with polynomials that we've been previously talking about. So addition, subtraction, multiplication, and division. And remember, the rules are all the same. So when we're adding, we're just going to combine like terms. When we're subtracting, we're going to change to addition and then make the signs in the second polynomial opposite. When we multiply, we're going to use FOIL if we're working with binomials or the distributive property for all other polynomials. And for division, we're going to separate the terms and simplify using the quotient property of exponents. But what's different in this lesson is that we're going to be working with mixed variables terms. So like 5x squared y. So the most important thing to remember is that you have to be very careful when you're combining like terms that you're only combining terms that have the exact same variables and the exact same exponents. So let's look at some examples. Suppose we want to simplify 5x squared y minus 3xy squared plus 4x squared y squared plus 3xy plus 4x squared y plus 3xy plus 5xy squared minus 4x squared y squared. So since I'm adding, I'm going to recopy the first polynomial, okay, exactly as it's written down. And then since I add vertically, I'm going to go ahead and line up the terms from the second polynomial that are exactly the same. So I have 4x squared y, so that's going to go right here under the exact same term, right? You see it has both has x's and they're both squared and they both have y's. Then 3xy is going to go with my 3xy term. Okay, so you kind of have to match the variables and exponents. Then I have 5xy squared, so that's going to go here with my other xy squared terms because we can only combine terms if they have the exact same variables and exact same exponents. And then we have minus 4x squared y squared. Okay, so now that we've lined up all the like terms, when we add, we're going to combine the coefficients and keep the variables the same. So 5 plus 4 is going to give me 9x squared y, and then minus 3 plus 5 is going to give me plus 2xy squared. Plus 4 minus 4, well, that's going to make 0. So these terms are going to essentially cancel each other out. And then plus, I have 3 plus 3, so that's going to be 6xy. So this is now the fully simplified form of this expression. So now let's try simplifying this expression. So once again, same idea, okay? I'm going to write down my first polynomial, 2a squared plus ab minus b squared, and I'm going to pick up the terms from the second polynomial that are exactly the same variable with same exponents. So minus 2a squared, then plus 5ab, and then plus b squared. Okay, so what happens here is 2a squared minus 2a squared, they cancel each other out. Plus ab and plus 5ab, well, ab, remember, is basically 1ab, right? So that's going to be 6ab. And then minus b squared and plus b squared, those also cancel each other out. So this fully simplifies to 6ab. So now let's try this problem. So here you can see we're subtracting, okay? So remember, when we're subtracting, what we're going to do is we're going to keep the first polynomial exactly as it is, okay? We're not going to change anything. But then what we're going to do is we're going to change that sign to an addition, okay? And then we're going to switch the signs on every term on the second polynomial. So it's going to be minus 3y minus 4x cubed y cubed plus xy cubed minus 4x cubed y. Okay, so now I'm going to write down all the terms in my first polynomial. Okay, so it's going to take me a minute to do that. And then I'm going to line those up with the terms from my second polynomial that are exactly the same. This minus 3y has no like terms, so I'm just going to leave it here at the end. Minus 4x cubed y cubed, well, here's my x cubed y cubed term, so I'm going to line those up. And then plus xy cubed, I'm going to put that here with my minus 4, so those two terms will line up. And then minus 4x cubed y, I'm going to put right here. So the terms that don't have anything to combine with, if you want, you can add in a plus 0 just to have a placeholder there, or you can just leave it blank. Okay, so minus 5 minus 4 gives me minus 9x cubed y cubed. Plus 7 minus 4 gives me plus 3x cubed y. Minus 4 plus x, well, minus 4 plus 1 is going to be minus 3, so we have minus 3xy cubed. 5x plus 0 is just 5x, and then I have my minus 3y. So this is the fully simplified form of this expression. So now let's try this example. So here we have another subtraction. So once again, I'm going to use the same strategy. I'm going to recopy my first polynomial, and then I'm going to switch it to a plus sign, and then switch all the signs in the second one to the opposite. So minus 4x cubed plus 3x squared y minus 5y cubed. And so now let's go ahead and line these up so we can just add them vertically. So plus xy squared plus y cubed, and then minus 4x cubed is going to go right here, okay, because those line up. 3x squared y is going to go with my other x squared y term. Minus 5y cubed is going to go here with my y cubed term. Xy squared has nothing to combine with, so I'm going to put a plus 0 as a placeholder. 4x cubed minus 4x cubed will cancel each other out. Minus 2 plus 3 is going to give me just 1x squared y. Plus xy squared, and 0 is just going to be plus xy squared. Y cubed is basically has a coefficient of 1, so 1 minus 5 is going to be minus 4y cubed. Remember, we don't need that coefficient of 1, so I'm just going to write this as x squared y plus xy squared minus 4y cubed. That's my fully simplified expression. Okay, so now let's try this one. This one says to simplify, but you can see what's happening here is I need to multiply these. And so they're not two binomials. So to multiply, I'm going to need to use the distributive property. That means I'm going to take each term in this first binomial and then multiply by the second. So first I'm going to do 2x times the whole thing of the second binomial, or not binomial, sorry, but second polynomial. And then I'm going to do minus 1 times the second polynomial. So 4xy squared plus xy minus 3y. Okay, so basically I have to use the distributive property here. So when I do 2x times 4xy squared, right, plus 2x times xy plus 2x times minus 3y, and then I have minus 1 times 4xy squared, and then minus 1 times xy, and then minus 1 times minus 3y. So now I'm going to go ahead and multiply everything. So 2 times 4 gives me 8. X times x gives me x squared, and then I have y squared. Plus, and then here I just have a 2. X times x is x squared, and then I have y. Plus, 2 times negative 3 is negative 6, and then I have xy. And then minus 1 times 4 is just going to be minus 4, and then I have xy squared, and then I have minus 1 times xy, so minus xy. Minus 1 times minus 3y is going to be plus 3y. Okay, so now let's go ahead and just simplify this. So I have 8x squared y squared plus 2x squared y. This plus minus is going to become a minus 6xy minus 4xy squared minus xy, and then plus 3y. Okay, so let's combine any like terms if we have them. So I have 8x squared y squared that has no like terms. And then I have a plus 2x squared y. And this minus 6xy and this minus xy can combine, which gives me minus 7xy. I have a minus 4xy squared and then plus 3y. Okay, so on those xy terms, you see you want to be careful and make sure that you're only combining the terms that have the same variables and the same exponents. So this is now the fully simplified form of our answer. So let's try this example. So here we have another multiplication. So once again, I'm going to use the distributive property. I'm going to do 3a times 2ab squared plus 5ab minus 3b. And then I have minus 4ab times 2ab squared plus 5ab minus 3b. Okay, so let's distribute 3a to all three of these terms. So we have 3a times 2ab squared plus 3a times 5ab plus 3a times minus 3b, and then minus 4ab times 2ab squared, and then minus 4ab times 5ab, and then minus 4ab times minus 3b. Okay, so 3a times 2ab squared, 3 times 2 gives me 6, a times a is a squared, and then I have b squared. So I have 3 times 5, so plus 15, and then a times a is a squared, and then b. And then 3a times minus 3b, so that's going to be minus 9ab. Minus 4 times 2 is minus 8. A times a is a squared, and then b times b squared is going to give me b cubed. And then I have minus 4 times 5, so minus 20. A times a is a squared. B times b is b squared. And then minus 4 times minus 3 is going to be plus 12. And then I have a, and then b times b is going to be b squared. Okay, now let's go through and simplify and combine like terms whenever we can. So I have 6a squared b squared, and I have a minus 20a squared b squared, right? So that's going to combine into minus 14a squared b squared. And then let's see, I have a 15a squared b, but I don't see any other a squared b terms. So I'm just going to write plus 15a squared b. I have a minus 9ab, but I don't have any other ab terms, so minus 9ab. I have minus 8a squared b cubed. I don't have any terms like that, so I have minus 8a squared b cubed. And then finally, I have 12ab squared, and that also doesn't combine with anything because there's no other ab squared terms. So this is now the fully simplified form of this answer. All right, now let's try simplifying this. This you can see is a division problem. Remember, our strategy in division is to break this apart. So I have 9x to the 6th y to the 4th over 3x cubed y squared, and then minus 15x to the 5th y cubed over 3x cubed y squared. Okay, so first I need to divide the coefficients. 9 divided by 3 is 3. Remember, when I have the exponents, I'm going to subtract the exponents. So I have x to the 6 minus 3, which is 3, y to the 4 minus 2, which is 2, and then minus 15 divided by 3, which is 5, and then I have x to the 5 minus 3, which is 2, and then I have y to the 3 minus 2, which is just y to the 1. So I'm just going to leave that as y. So this is now our fully simplified answer. Okay, so now let's try this problem. So here, once again, I have a division, so I'm just going to separate each of these terms. So I have 12x to the 4th y over 4xy plus 8x cubed y squared over 4xy minus 16x squared y to the 4th over 4xy plus 4x squared y squared over 4xy. Okay, so first we're going to divide coefficients. So 12 divided by 4 is 3. And then x to the 4 minus 1, so x cubed. Y over y will just cancel. And then plus 8 over 4 is 2. X to the 3 over x to the 1, I subtract the exponents, giving me x squared. Y squared over y to the 1, subtract the exponents, so I just have y. Minus 16 divided by 4 is 4. X to the 2 over x to the 1, I subtract the exponent, so I have x to the 1, which is just x. Y to the 4th over y to the 1, I subtract the exponent, so I have y cubed. And then I have plus 4 over 4 cancels. X squared over x to the 1, I subtract the exponents, and I just have x. Y squared over y to the 1, once again, subtract the exponents, and I have y. If I look at my final answer, I don't have any like terms that I can combine, so I'm just going to go ahead and leave this as it is.